Hello everyone, this is Kalpana here. In this video, we're going to see a problem from Legender's equation. So let's get going. Problem: solve 2x plus 3 whole square into d square minus 2 into 2 times, minus 2 times 2x plus 3 into d minus 12 into y equal to 6x. So the given differential equation is of the form ax plus b whole square into d square plus sum p1 into ax plus b into d plus sum p3, otherwise sum pn, whatever. Here we have p1, so this will be of p2 into y equal to some function of x, right, which is the Legender's equation. We know that Legender's equation is of the form ax plus b power n into d power n plus some constant p1 into ax plus b power n minus 1 into d power n minus 1 plus so on plus pn into y equal to q. Here p1, p2, so on, pn are real constants and q is a function of x. These are Legender's equation. So the given differential equation, we can say that the given differential equation is in Legender's equation form, right? Solution: given differential equation, (2x plus 3 whole square into d square minus 2 times 2x plus 3 into d minus 12 into y equal to 6x). Consider as equation 1, which is Legender's equation, right? Now we'll reduce the Legender's equation or equation 1 to a linear differential equation with constant equations by making some substitutions. We know that from Legender's equation, or the procedure to solve Legender's equation, ax plus b is replaced by e power z, or we'll substitute ax plus b by e power z. Okay, then z equal to log of ax plus b. By making these substitutions, we'll get theta equal to d by dz, and ax plus b into d becomes a into theta, ax plus b whole square into d square can be replaced by a square into, here you're having ax plus b whole square into d square, right? So you'll get theta of theta minus 1, product of 2. Ax plus b whole cube into d cube can be replaced by a cube into theta of theta minus 1, theta minus 2, product of 3 terms. Okay, if you get 3 power 3, you'll get product of 3 terms. If you get power 2, you'll get product of 2 terms. If you'll get 1, you'll just get 1 term, theta. Fine. Now coming to our problem. Let 2x plus 3 equal to e power z, then z equal to log of 2x plus 3, and theta equal to d by dz, and 2x plus 3 into d equal to a into theta, 2x plus 3 whole square into d square equal to 2 square into, it's a square, right? So you'll get product of 2 terms, theta into theta minus 1, right? Now let's make the substitution in equation 1. Then 1 becomes 2x plus 3 whole square into d square can be replaced by 2 square into theta of theta minus 1 minus 2 into 2x plus 3 into d can be replaced by 2 theta minus 12 into y equal to 6 into x. You need x, right? Value of x in terms of z. Here we have 2x plus 3 equal to e power z, right? Now take this 3 to RHS, then you'll get 2x equal to e power z minus 3, right? Now take this 2 to RHS, then you'll get x equal to e power z minus 3 by 2. So you got the value of x, right? Since x equal to e power z minus 3 by 2, then the RHS part becomes 6 times e power z minus 3 by 2, right? Now let's simplify this. This becomes 2 square 4, theta into theta, theta square, minus 4 theta into 1 is 4 theta, minus 2 into 2 theta is 4 theta, minus 12 into y equal to 3 times e power z minus 3, right? This gives us 4 theta square minus 4 theta minus 4 theta is minus 8 theta minus 12 into y equal to 3 e power z minus 3, 3 is 9, which is an operator form, say f of theta, that is function of theta into y equal to some function in z and constant, right? Function in z and constant. I'll consider this as r and this as f of theta, which is of the form f of theta into y equal to some r, where f of theta equal to 4 theta square minus 8 theta minus 12 and r equal to 3 e power z minus 9, right? So we have reduced the given differential equation, that is Legender's, to a linear differential equation with constant coefficients form, right? This is a linear differential equation with constant coefficient in terms of theta and z. Consider this equation as equation 2. Now we'll find the general solution to this equation 2, which comes in terms of z, and later we'll find the general solution to this equation. Using the solution of 2, we'll get the general solution of 1. Okay, and the general solution of this equation is given by y equal to yc plus yp. Here yc comes from auxiliary equation, and we'll get yp using 1 by f of theta into r, that is RHS part. Okay, let's see. Let's begin with auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of theta 4 theta square minus 8 theta minus 12, right? Let's replace m in f of theta, then we'll get f of m equal to 4m square minus 8m minus 12. Then the auxiliary equation becomes 4m square minus 8m minus 12 equal to 0. Now take 4 common from all these terms. We'll get 4 times m square minus 2m minus 3 equal to 0, which gives us m square minus 2m minus 3 equal to 0, right? Now we need to find roots to this equation, so that we'll write minus 2m as minus 3m plus m. Minus 3m plus m is minus 2m again, right? So now take m common from the first two terms, we'll get m times m minus 3, and write the next two terms as it is. Now take m minus 3 common from these two terms, we'll get m minus 3 into m plus 1 equal to 0. Now equate each factor to 0. When m minus 3 equal to 0, we'll get m equal to 3, and when m plus 1 equal to 0, we'll get m equal to minus 1, right? So this gives us m equal to 3 and minus 1, which are the roots to this auxiliary equation, and the roots are real and distinct, right? The roots are real and distinct. Therefore m equal to 3 minus 1 the roots are real and distinct. We know that when two roots m1 and m2 are real and distinct, then yc will be c1 into e power 1 root into the variable z plus c2 another constant into e power another root into variable z, right? Because here the equation is in terms of z, so we are using z instead of x. Don't get confused, right? Now coming to our complementary function, yc equal to c1 into e power 1 root, say 3 into z plus another constant into e power another root into z. This gives us c1 e power 3z plus c2 e power minus z, or we can write this as c1 e power z. We can write e power 3z as e power z whole cube plus c2 into e power minus z can be written as e power z power minus 1. Okay, fine. Therefore yc equals to c1 e power 3z plus c2 e power minus z. Now coming to yp. Yp is given by 1 by f of theta into RHS part. This is equals to RHS part of equation 2. Here f of theta is 4 theta square minus 8 theta minus 12 and r is 3 e power z minus 9. Right? We can write this as 1 by 4 theta square minus 8 theta minus 12 into 3 e power z minus 1 by 4 theta square minus 8 theta minus 12 into 9. We can write 9 as 9 into 1 for our convenience, since we know that e power 0 equal to 1, right? We can write 1 as e power 0 and we can write e power 0 as e power 0 into z. We'll just replace this 1 by e power 0z in the next step. Now this becomes, first term remains the same. Here we'll replace 1 by e power 0z, right? Again we'll write this as constant, that is 3 into 1 by f of theta into e power z minus constant 9 into 1 by 4 theta square minus 8 theta minus 12 into e power 0z. Okay. So we have f of theta equal to 4 theta square minus 8 theta minus 12, right? Let's now find f of 1. Here the coefficient of z is 1, right? So we'll find f of 1 here. Just replace theta by 1, then we'll get f of 1. 4 minus 8 minus 12. 4 minus 8 is minus 4 minus 4 minus 12 is minus 16, which is non-zero. Since f of 1 is non-zero, so we can replace theta by 1 in the first term. Now coming to the second term, here also this is of, see this is of 1 by f of theta into e power az type. Here we are having r of e power az type, right? So we are applying this method. So for the second term, we need to find f of 0. F of 0 equal to, just replace theta by 0, you'll get 0 minus 0 minus 12, which is minus 12. Again a non-zero, since the denominator is non-zero. By applying theta or by replacing theta by 1, so we can replace theta by 0 here. Here also f of 1, or by replacing theta by 1, the denominator becomes non-zero, so we'll replace theta by 1 here. Okay, then this becomes 3 into, since f of 1 is non-zero and f of 0 is a non-zero, So this becomes 3 into, we'll just replace theta by 1 here. We'll get 1 by 4 into 1 square minus 8 into 1 minus 12 into e power z minus 9 into 1 by, since f of 0 is not equal to 0, so we'll just replace theta by 0, then you'll get 4 times 0 square minus 8 into 0 minus 12 into e power 0 z. Right? Fine. Now this becomes 3 times 1 by 4 into 1 square is 4 minus 8 into 1 is 8 minus 12 into e power z minus 9 into 1 by 0 minus 0 minus 12 into e power 0 into z. This equals to e power 0 into z can be written as e power 0 otherwise, right? 3 into 1 by 4 minus 8 is minus 4 minus 4 minus 12 is minus 16 into e power z minus 9 into 1 by minus 12 into, since e power 0 is 1, so you'll get into 1. This is equals to 3 into, you can write this as minus 1 by 16 into e power z, minus into minus, okay, right, let it be, minus 1 by 12. Now we can write this as 3 into minus 1 by 16 into e power z can be written as minus 3 by 16 into e power z, right? Minus into minus plus, 3 3s are 3 4s are 12, right? So you'll get plus 3 by 4 here. Therefore yp equal to minus 3 by 16 into e power z plus 3 by 4. We got yp and yc. Now we can find the general solution to equation 2, which is given by y equal to yc plus yp. Therefore, the general solution to equation 2 is given by y equal to yc plus yp. So here we'll get the general solution in terms of z, okay, which is the solution to equation 2. Y equal to yc is c1 e power 3z plus c2 e power minus z, and yp is minus 3 by 16 e power z plus 3 by 4. See, which is in terms of z, right? This is the solution to the reduced equation, that is the linear differential equation and constant coefficients. Fine. Now we'll find the general solution to this equation using this solution. Now we have y equal to c1 e power 3z. I'll write it, okay. I'll write as it is. Now just write e power 3z as e power z whole cube, since we need to replace e power z by 2x plus 3 in order to find the general solution to the given equation. Plus c2 into, write e power minus z as e power z power minus 1 minus 3 by 16 into e power z plus 3 by 4. Okay. Now replace e power z by 2x plus 3. Replace e power z by 2x plus 3. Here we don't have any z, right? We just have e power z. So just replace e power z by 2x plus 3. Then this becomes y equal to c1 2x plus 3 whole cube plus c2 2x plus 3 power minus 1 minus of 3 by 16 into e power z 2x plus 3 plus 3 by 4, which is an equation in terms of x, right? Therefore y equal to c1 into 2x plus 3 whole cube plus c2 into 2x plus 3 power minus 1 minus 3 by 16 into 2x plus 3 plus 3 by 4 is the required solution, is the general solution to equation 1, that is the given differential equation. Well, we have seen a differential equation, that is Legender's equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.